By the way, guys, if you take a look at the folder that I gave you guys, I've also uploaded the video from yesterday. That's the 567 meg file. That's the zip file or the RAR file for the video from yesterday. So if you want to download that, you can do that in this particular folder over here. All right. So with that in mind, what's the agenda for today? First thing, we'll do a review of MPLS VPNs, what we talked about yesterday, and then we'll build up on it. We'll actually implement the entire MPLS VPN. What are the different things that we'll do? We'll do the PEC routing protocols. We'll take a look at EIGRP, RIP again. We'll do OSPF. We will do BGP. And if you want, we can also do ISIs. All right. Once this is done, we will also under intra AS MPLS VPN, that means within the same AS, we'll also take a look at extranets, basically connecting two different VRFs or exchanging routes from one VRF to the other using export maps. So a lot of good stuff over here as well. Once this is done, I will also show you how to do an intra-AS MPLS VPN route and data path segregation. Basically using route reflectors with MPBGP. That's the other thing that we'll take a look at. Now, if you're done with all that, we'll go into inter-AS MPLS VPN. We'll probably do one option today, option A, and the rest we'll leave for tomorrow. So tomorrow we'll do option B, option C, and we'll also take a look at how to do the same lab on iOS XR. That's a plan for the class. All right. So let me bring up the same topology that I had from yesterday, and we'll set it up from scratch. VRF Lite does not necessarily work with MPLS VPN. VRF Lite is basically where you don't have to use the route targets for VPNs. It's just pure segregation that you might want to do between two segments of your router, but not running MPLS VPN. That's VRF Lite. So VRF Lite is creating VRS without using RD and RT values. So we're going beyond that. The VRF Lite would be that. So this is the plan over here. This is what we're going to be covering. To bring it up, this is the topology from yesterday, if you guys remember. And today I'm going to focus on the MPLS VPN part. What are the steps to get it done? So you guys are comfortable with setting it up. And I'll approach it as a step-by-step process, so you feel very comfortable in terms of what is the process that's taking place. If something's not working, what would be the cause of that not working? All right. So pay attention, guys. I try to make it as simple as possible to do MPLS VPN and try to teach it like that. First things first, in order to do MPLS VPN, which is allowing my customer site over here, R5, to connect up to my customer site, same customer site over here. At the same time, the service provider also has another customer, which is this green customer, 6 and 7. They want to talk to each other. The router that represents the customer network over here is known as the customer edge router. The router that represents the service provider network over here is known as the provider edge router. This is again a review from yesterday. So when I receive a route from E01 over here, I'll put them in a different VRF than the routes received from E02. So initially, when I receive the route, I need to make sure that they're unique routes. So I'll receive them in their own VRFs. But then to propagate the routes from one PE router to the other, I need to put them in a common table over here, which is going to take the route from one PE and send it to the other PE. All right? Everybody okay with that? And this table, known as the MPBGP table, will receive the routes. To make them these routes unique, I need to have a prefix assigned to all the routes from a particular VRF. This prefix is known as the route distinguisher. The RD. What's the size of the RD, if you guys remember? 64 bits broken down into 32:32 bits. This generally is your AS number. This is generally your customer number. All right. So when I receive a route from customer, it'll be 100:1:10:110. I showed it to you guys yesterday. And the same 10:1:1 route received from R6 would have been 100:2:10:110. Be put into this common table called the VPN v4 table, and I'll use MPBGP to propagate the route from one PE router to the other PE router. All good? LSPs are unidirectional. Dardy, just put the message to everyone so everyone sees the messages. It's like normal routing. When I do routing, I always take care of how do I reach a particular destination. I really don't care how about the reverse path is coming in. So same concept over here. When a route gets propagated from A to B, I don't really care how B comes back to me. You get my point? And that is his responsibility. Think about MPLS VPNs over here. Let's say I set up a route. Let's say I had this type of setup over here. Using PBR, we can use traffic engineering later on. I have the ability to send the route from here to here to here. But that doesn't necessarily mean the reverse route should come the same path. It might use a different path to come back. Maybe because of manipulation of routes or paths or costs. So whenever you do LSPs or normal routing, Darty, it is always unidirectional. I don't dictate the return path. That's the reason that your label switch paths are unidirectional, just like normal routing. You get my point? So it follows the same pattern of your normal routing. So again, this is what I need to do to get the route from my VRF into where? Into my common table. So I have two VRFs, VRF for A and VRF for B. I'll take the route and put it into the common table, but in the common table, the route is not a 32-bit route, it becomes a 96-bit route. And what was that 96-bit route called? You guys remember the name for the 96-bit route? VPN v4. And MPBGP was the variation of BGP that allowed it to propagate a 96-bit route versus a 32-bit route. Gets a route across to the other side. Now, once a route is over here in my VPN v4 table over here, what is used to take the route from the VPN v4 table and propagate it into the appropriate VRF? You guys remember what I told you about the RD? The RD is there only to make the route unique. It is not going to be used to propagate the route into the appropriate destination VRF. That is done by using this community attribute called the route target. So at the time I put the route from my VRF into my VPN v4 table, I will tag the route, this 100:1. This is my route distinguisher. 10:1:10. This is my actual IPv4 route. Will have an attribute, an extended community attribute called the RT. let's say 1:1 is my export RT. So this route that went from my VRF-A into my MPBGP table, VPNv4 table, it will have a tag set to 1:1. So the other VRF on the other side will have an import RT where it will go in and it will search what? It will search the VPNv4 table for any routes that have an RT value set to what? 1:1. I need to match the RT value between the two ends. So if I'm exporting 1:1 on this side, I need to import 1:1 on this side. Does that make sense, you guys? Everybody okay with that? The other thing that I wanted to clear up from yesterday is that RD and RT values do not need to be the same. It's recommended that you keep it the same, but purposely what I had done for the first VRF was I had kept it different. I had kept my RD for the VRF as 100:1 and I kept my RT as 1:1, which is not recommended, but that's just to prove a point that you can have them differently. I would set it up differently. So if I exporting 1:1 over here, what do I need to import on the VRF on this side? I need to import the RT as 1:1. Understood, guys? Everybody okay with that? And that is your, what do you call it? The way that you take the route from the VPNv4 table and put it into the appropriate VRF. We'll take a look at that. When we're doing the extranets, where you want a route to propagate into a particular site or particular VRF and not into another one, you have the ability to have multiple RTs assigned to different routes. So in my case, later on, when I want to do the exchange between the two different customers, I'm going to assign different RT values to different routes. So you have the capability of doing that. So it gives you the flexibility of taking a route and putting it into a particular VRF and not into another. All right, but the RD will be a common RD for the entire set of routes in that particular VRF. Good so far? So now let's go ahead and set this up. We'll do it from scratch in the sense that what I want to do is I want to take the route from customer A over here. Customer A on this side is running RIP as a routing protocol. So he has agreed with the provider to run RIP as your PEC protocol. Not a very common thing to do, but I just want you guys to see how to run RIP inside a VRF. That's the reason I'm running it over here. And the other thing that I want you guys to see is one side of the customer A is running RIP and the other side is running same customer. Their internal network over here is running OSPF. Is it possible to take the RIP route and send it into another side as OSPF? Absolutely possible, and I'll show you how that's done. Good so far, guys? Everybody okay with this? You need to understand you have a RIP domain over here. The middle domain over here is going to be MPBGP. And in this case, I have another domain on the other side, which is OSPF. So you're going to have redistribution done from RIP to MPBGP and from MPBGP into OSPF. And from OSPF, I'm going to take the routes from OSPF, send them to MPBGP, and from MPBGP into RIP. We'll take a look at the steps over here. So now I'm doing it from scratch. What are the things that I need to do to set this network up? Besides the IP addressing, what are my main steps of setting up an MPLS VPN? So when I take a look at any type of task, what I try to do is I break the task down into small sub-steps. And that's exactly what I want to do with MPLS VPNs as well. What are my tasks that I need to do over here? Number one, configure the SP core with an IGP. Pick an IGP, whatever you want, set it up. In my case, I'm running EIGRP because it's quicker to converge, but you can run any IGP. The purpose of the IGP over here is to provide reachability, the network reachability of your PE routers. How does one PE router, one edge talk to another PE router on the other side? That's the purpose of IGP over here. Number two, configure the SP core with MPLS unicast routing. Now you need to understand one thing over here. To exchange MPBGP routes from one edge to the other edge, this step is not required. I would be able to exchange the routes from the customer edge, router 5 to router 1, and from router 1 to router 4, from router 4 to router 8, exchange the control plane, that is the routing domain, without running MPLS in the core, because all I need for that is pure IP reachability is all I require to get the route from R1 to R4. Even if I'm not running MPLS unicast routing over here, no labeling, I can still get the route. Route propagation happen from here to here. This can be just based on IP. Understand? I don't need any labels for that. But once a route comes in over here, I have the route in my routing table. I want to generate some data for it. When I generate the data, I'm going to be using the routes that I've received from the other side. So I would receive, let's say, 10.1. So my data packet at that point actually references those routes. So I'm going to send a packet from 10.2 to 10.1. That time, when the packet is received on R4, it will have this as the destination. So the destination, when it gets it, it would have learned it from R1 because I have an MPBGP over here. So the forwarding of the packet would go through here with the destination of 10.2 and 10.1. And these two guys are completely aware of 10.2 and 10.1. You get my point. So to exchange the routes, I don't need IP. I don't need MPLS. IP is good enough. That should answer your question, Hari, from earlier on. So you're saying that MPLS unicast routing is only using IP and thus only looking at the fib. No. What I'm saying is if I want to do MPLS VPNs, okay? If I'm doing MPLS VPNs, Ernie, to exchange the routes for my VPN routes from my customer, what happens is I'm going to send a route over here to RIP, for example. Router 1 receives it. Router 1 needs to exchange the route to R4. When he creates a packet to exchange the 10.1 or 10.5 routes with R4, the packet looks like this. The packet is going to have 10 dot, not 10 dot, sorry. It's going to have 1.1.1.1 going to 4444 as the header. This is a BGP update that's going. Okay, and in there it'll say I'm exchanging routes 10.1.1.0 and 10.5.5.0 along with that RD value. For this packet to propagate from R1 to R4, all I need is an IGP. I need connectivity between R1 and R4. That's all I need. That's the control plane. But the problem will come in when he receives the 10.1 and 10.5 route. Only R1 and R4 would be aware of 10.1 and 10.5 route. So I need to have a mechanism of getting the data packet, which is from 10.2 to 10.1, propagated from R4 to R1 to the core without having to do an IP lookup in the core. And that's where MPLS unicast routing comes in. So MPLS unicast routing, the labeling part, only comes in the picture when you're doing the data transfer, not at the time of the control plane transfer. Stein, you're absolutely right. Data plane is reliant on their labeling happening in the DSP network so that I don't do a label, I don't do a L3 lookup where on the core routers. Ernie, good with that? Are you good for that? Because both these questions were related, what you had asked and what Ernie's asked. But because I know correct. R1 and R4, you would exchange the routes, you would see the routes, but it would not work in terms of pinging because you probably are not running MPLS unicast routing in the middle. You're talking about the VPN v4 label? Okay, we'll talk about that when we get to that point. We haven't gotten to that point yet. So you guys are okay with that. But because I know I'm going to be running what MPLS VPN, I included as one of the steps that is required. Configure the SP core with MPLS unicast routing, because I am planning on sending data across. I'm not just going to exchange the routes. I also want data to go across. So that's why I need MPLS unicast routing. Okay. Number 3, third step, configure the MPBGP relationship between the PE routers. All right, that would be my third step. Okay, so when I'm doing MPLS VPN, I would start with IGP in the core. Step 2, run MPLS in the core, the unicast routing part of it, configure MPBGP between the PE routers. Once this is done, now I'm ready to configure the PE router. Yes, you would, but it's a point-to-point tunnel. What if I had 15 PE routers? Configure the PE router. Let's go through these steps. Most of the answers most of these questions would be answered. Configure the PE router. The main things that I'm doing when I'm doing this: VRF, create the VRF, assign the interface to the VRF. And the third thing that I do at this point is configure the PECE routing protocol. These are the 3 steps that I would take on my PE router. Last step, configure the CE router. What am I doing over here? Basic routing. And these are the steps that I need to do to configure what? MPLS. Guys, focus on this. We'll answer those things later on. Forget this for right now. So these are the steps that I need to do over here. Let me bring my topology up and see this over here. I'll bring up I have 8 devices. Let me just bring all of them up. I'll use them at a given time. 5. These are my CE routers. I'll just do the would you like note to it. I don't need to wait for them to come up. Now R1, R4, R1, R2, R3, R4 are my 4 routers, correct? R1, R2, R3, R4. These are my service provider routers. R1 and R4 are my PE routers. These are my core routers within the service provider. So the first step over here, first task over here is to configure what? The IGP over here, okay? Any IGP would suffice unless you're doing something like MPS traffic engineering. That would require you to run OSPF or ISIS as your protocol over here. So let's see what I'm running. If I'm running anything, let's go to router 1. Let's check it out. Show IP protocols. I am running EIGRP and AS100. Let's check my config. So I'm running 1 and the 12 network in EIGRP. You guys should have this diagram as well, so you can load it up so you guys can follow along in terms of the path. So I have the loopback over here on PE router and the 12 network. I'm running that in EIGRP. Router 2 should be running 23, 12, and the 2 network. Router 3 should be running 23, 34, and the loopback 3 network. Router 4 is running the loopback and the 34 network. All right. So if I look at my routing table at this point, for EIGRP, I learned the 2, the 3, the 4, the 23, and 34 networks. No, not necessarily. It would be ISIS or what do you call it, OSPF. The reason I run it is EIGRP converges faster. That's the only reason I'm running it. And I'm not doing MPLS TE at this point, so I don't really care. But yeah, in a service provider network, it would be ISIS or OSPF. My main objective over here is to provide reachability. So those protocols at this point would not have mattered to me. So this step over here, guys, are you guys okay with this? Step number 1. All good? Simple connectivity within the core so the P routers can reach each other. Number 2, configure what? MPLS unicast routing. This step I do want to configure over here. All right, because I don't think I have. Show MPLS interfaces. I don't have them. R1 should be able to ping R4. Correct. Absolutely. That's why I checked your routing table over here. But this would be an IP packet at this point. So if I do a trace route, I have reachability. And in order to exchange the routes, actual routing protocols, this is all I need. I don't need LDP for this. I don't need labeling for this. Data path would require labeling like that, but my control plane would work even with this. Okay, but I know I'm going to be doing data, so let's do my second step, which is running MPLS unicast routing. Which interfaces should I enable MPLS on over here? Help me out. This one? Core interfaces, correct? This side. So let's do that real quick, and I'm going to use the loopback as my router ID. I'm going to configure that. So R1, MPLS, LDP router ID, loopback 0, interface E0/0, MPLS IP. Router 1 only has one interface, so this is good enough. Router 4 is also like that, so to save some time, I'm going to do 4 as well, because R4 also has it only enabled on one interface. Router 2 and router 3, if you look at your diagram, will be enabled on two interfaces, E00 and E00 and E01. Not necessary. Yesterday, I just wanted you guys to see that the labels are different. Here today, I don't really care about what the labels are, because I'm going to rely on them meaning LDP, to assign labels and make sure the labels get propagated. So I really don't care what the label number is per se. So router 2, I'm going to do it on two interfaces. My first LDP neighbor relationship came up, and my other one should have two neighbor relationships come up on R3. With 2 as well as with 4. There you go. So now if I do the same trace route over here, it should be a labeled exchange between what? R1 and R4. Good so far? That takes care of my second step over here. So this is my first step. It's my second step, along with the commands. Now my third step over here is another easy one. Configure BGP or MPBGP between what? My provider edge routers. In my case, my provider edge routers are router 1 and router 4. How do I do that? Router BGP 100, neighbor. I need to enable the normal neighbor commands that I would do, remote AS is 100, update source loopback 0. Now, is this update source loopback 0 a required command or a recommended command? Can I do it based on the physical load? Normal speaking, when you're doing normal BGP, it's a recommended command. But when you're doing MPLS VPNs, it becomes a required command. The reason is if you don't do it, your popping of the label will happen in the core. No, not because of that, not because it's sourced from the egress. The problem will be if I do it based on, let's say I do it based on the physical interface. So my source interface becomes, MPLS doesn't require it. MPLS VPNs requires it. And the reason for that is this. If I do my BGP neighbor relationship like this, from my 192.1.12.1 network towards 192.1.34.4 network. Okay? And Stein, even for your answer, I don't think your answer was completely proper. You have to do it based on loopback to loopback. So even if you do update source loopback on one, but you point to the other side as a physical interface, you would have the same problem. The problem over here is this. When I receive the route on R4, that 10.5 route, for example, on R4, it'll say 10.5 is reachable via 192.1.12.1. Agree? Because my neighbor relationship in BGP is based on what? Physical interfaces. Yeah? You understand that? So everybody follow this so far? Now, understand this. Let me finish this and you'll understand why it's a requirement. Not for that ISP filtering and all that type of stuff. There's nothing to do with it. So when I receive 10.5, I'm receiving it from what? 12.1? Everybody understand this? Don't think I'll give you the answer. Just follow along. So 10.5 is reachable via 12.1. So when the packet comes in, he needs to send the packet from, let's say, 10.2 trying to reach 10.5. When he gets a packet, he will say, oh, I need to get to 12.1. 12.1 has a label. The label would have been generated because this is also an MPLS, what do you call it? Interface. It would have been generating a label for it as well. So I would get a label over here. So I would put a label and send it to R3 as a label packet. Okay. Now, when R3 receives the packet for the label for 12.1, isn't 12.1 directly connected to R1? Oh, sorry, R to R2? Is 12.0 or 12.1 directly connected to R2? It is. What type of label would R2 send towards R3? Pop, right? Implicit null. So R3, when he receives the packet, he has been instructed to pop this label because the label is for what? 12.x. So when he receives the route, he will be receiving the route as the IP route. And he will not know about 10.5 because 10.5 is something that is over here. You understand that? So by doing it based on the physical, the popping of the label will happen on the router before the PHP, before the penultimate hop, which exposes the VPN packet inside the core. So how do I avoid that? If I do my neighbor relationship based on the loopbacks, Now he's going to send the pop to him, to R2. Who's the popping router now? R2, which is okay. I don't want R3 popping the packet. I want R2 to be popping the packet for him, and I want R3 to be popping the packet for R4. You get my point? So what you need to do over here, which was a recommended thing in normal BGP, becomes a required thing in MPLS based systems where you have MPBGP running. So always set up the MPBGP relationship based on what? Based on your loopbacks. Do not set it up based on your what do you call it? Based on physical interfaces. Got it? Everybody okay with that? Do you understand why? So it's not like, oh yeah, I do it most of the time. It's just best practice. It is not best practice. It's a required practice. Clear? So again, over here, I would set the neighbor relationship based on the loopback. And then because I want to run, correct, then again, then you would need to do the explicit null and all those type of things. Rather than doing that, just do it based on this. Why complicate things? VPN v4, I need to activate it for this particular neighbor. There you guys, everybody okay with this? And similarly on R4, I'm going to do the same thing for what? Towards R1. Ooh, what did I do? There you go. R1, set it up. R4, set it up. So now I should have, what do you call it? A relationship between the two devices. A bunch of trainers say that the loopback has to be /32, but that's not true, is it? It's not true, but it's an issue that you might face in OSPF. Okay? It doesn't have to be /32. In my case, I'm not using it. See, if you take a look at my interface over here, I'm not using /32 and mine will work absolutely okay. I'll guarantee it to you. The reason OSPF will have an issue with it because locally the route will be a /8 route, for example, in this case. But when OSPF sends a loopback, it sends it as /32. So the other guy will see the route as a /32 route. When they exchange the labels, there'll be a missing label, an incomplete label, because I'm seeing it as a /8, the other guy is seeing it as /32. That's why it's recommended you do a /32. But even if you don't do a /32, you can always go into the loopback and set the OSPF network type to point to point, and it'll still work okay, even in OSPF. So it's more of an OSPF issue rather than it has to be 32. Understood? I'm going to use /8. It's absolutely okay. So my third step is also done over here, which is configuring the MPBGP relationship between the PE routers. Now the next thing, again, something that we did yesterday, configure the PE router, which is create the VRF, assign the interface to the VRF, configure the PEC routing protocol. All right. Let's do that step now. What are the substeps over here for this guy on R1? Step A, create the VRF. No, before the IGP, I'll create the VRF first. How do I create it? VRF definition. Let's call it cust A. Give it an RD value 100:1. Address family IPv4. I'm enabling IPv4 for this customer so that he can send me IPv4 routes. In here, I'm going to specify my route target that I'm going to be exporting to the other guy. Let's do a 1:1 over here. And just to make, then you would need to say address family IPv6 as well. In the newer iOSs, if you don't specify the address family IPv4, it doesn't enable IPv4, the address family on that in that VRF. So you need to enable it. This is enabling the address family. Even if I'm doing VRF Lite, I still require this command, even if I'm not doing any route target export. So route target import, just for the heck of it, I'm going to do 1:2. What does that mean now? When I'm doing this on R1 for cust-A, I'm saying when I send my routes into my VPNv4 table, my routes on R1, which are coming from R5, will have a route target of 1:1. So what does that mean on R4 when I create my cust-A VRF? What does he need to do? He needs to import 1:1 because I'm exporting 1:1. It's not a good practice to keep it like that, but I just want you guys to see they don't need to match. And at the same time, because I'm importing 1:1, what does that imply? That means he is exporting 1:2. You guys agree? You guys understand what I'm doing? And this is not something that people do, but I want you guys to see the capability is there. I don't need to match the RT values. As long as I'm exporting the right one, the other guy's importing the right one. I'm exporting the correct one on the other side. I'm importing that same one over here. Understood? On the second VRF, we'll do a simple one, the normal one. But here, I want you guys to see this. So once this is done, the next step over here, B, is assign the interface. So assign the VRF to the interface, or vice versa, however you want to take it. So in my case, that interface over here happens to be E01, and I'm going to assign it 192.1.15.1 as the IP. So interface E0/1, IP address 192.15.1. Oops. Don't forget, do this first, otherwise it blows the config away if you do it at the end. So always start by making the interface part of that VRF. It will blow any existing config on it. Then you put the IP on. Once this is done, step number C, configure the PE/CE protocol. What am I running over here? Step 4, configure the PE router? No, for the customer. I've done the MPBGP relationship already in step number 3. See this? MPBGP is done already in step 3. So configure the PE/CE protocol. What is the protocol that I'm running with R5? It is RIP. So yesterday we talked about how to run RIP, router, RIP. Inside RIP, don't do the commands directly under RIP. You need to do it under the VRF. That is done by using the address family, IPv4 VRF cust-A command. That means this RIP is running within the VRF. No auto summary. Normal RIP commands at this point. Network, the only network that I'm enabling is the 50 network. That is the network words customer. Now, one more thing that you also need to understand is redistribution at this point. When the route comes in over here into the VRF, it is going to be a RIP route. Agreed? I need to take this RIP route and send it into what? BGP. So I need to redistribute what? RIP into BGP. Not only that, the route from my other site will come in using OSPF into what? Into my VRF. From the VRF, he would have taken that route and put it into what? Into the VPNv4 table. That route again becomes a BGP route. So the exchange over here is BGP. So that OSPF route now becomes a BGP route on R1. You guys understand that? You get my point? Everybody follow? So the route came in as RIP. I took it in the VRF, redistributed it, and sent it into the VPNv4 table, which becomes a BGP route. OSPF on the other side did the same thing. Send the route into the VRF, which got redistributed into the VPNv4 table, and I exchanged it. So the route, the OSPF route, let's say it is 10.8, for example, over here. That route over here will be a BGP route. Now I need to take that BGP route and send it into my RIP neighbor. So I also need to do redistribution between what? BGP and RIP. So I'm preparing my redistribution because I know it's going to be a BGP route. I need to send it into a RIP neighbor. So over here, at this point, I am sending my BGP route from AS100 into what? Into RIP. So whatever route I learned from my PE router, which is basically the route that came in from the other site, I need to redistribute it and send it into what? Into RIP. And I'll go into BGP, into the address family, IPv4 VRF CAST, and this is the redistribution of the RIP route into BGP. This is the one, I'll put a description over here. Redistributes, so description, redistributes customer routes into the VPNv4 table. And this redistribution was to take the BGP routes and send them into what? Into your, what do you call it? Into your CE route. Everybody okay with this? You guys understand these steps? This is your configuration of your PE router on one side, on R1. Cool? Take a look at it and tell me if you guys are okay with this. Copy it. Let's go to router 1 and paste it. Good so far? Now, I'm not going to do R4 yet. I want you guys to see something. So let me finish one side and then I'll come in and to the other side. So the last step over here, based on my steps over here, is to do what? Configure the CE router, which in my case is R5. So what would I do on R5? Really simple. He is not aware of any VRFs, or he doesn't need to do any VRFs. Configure the CE router. This is R5. We'll do it from scratch. En config T, no IP domain dash lookup line con 0 log sync no exec timeout. Host name is R5. My interface is E0/0 15.5 because R1 is 15.1. Same network. I'm going to simulate some internal loopbacks by creating IP address 10.1.1.1. No IP domain. Look, LO is good enough. This is fine. And then loopback 1, IP address 10.5.5.5. Based on the diagram that you guys have, router RIP, version 2, no auto summary, network is 15.0, and network is 10.0. So let's copy this. And R5 will paste it. And to see the result of it, show IP route VRF cast A. Everybody okay with this? So my first place, my first checkpoint over here is that I'm getting the route in my PE router. Good. What's the next place that it should be in? So I got the route from my customer edge router, propagated into my PE router. Inside my PE router, what's the first place that I receive this route into? Into my VRF, right? And it's showing over here. All right. What's the next thing? This is your VRF for this customer. What's the next place it should go to? The VPN v4 table, right? And what would take the route from this guy to this guy? What was the process? How would I take the route from the VRF into the VPN v4? RD, yeah, but redistributing. When you do the redistribution, it takes the RD value, but the process, the command is redistribution to take the route from what? The VRF and put it into the VPN v4 table. Have I done that? I think I did, right? As part of my config. So let's see if that's there. How do I check this table? What I would suggest that you do is create an alias for this, alias exec. I call it SVPN, show BGP, VPN v4, unicast all long command. So now I can just do show SVPN. It's not there. Okay, did I put that in over here? Address family IPv4. I don't think I copied it. I put it in Notepad for sure. Let's check. Okay, yeah, description is under the interface. Yeah. So now I've done it. It's taken it. So now let's do show SVPN. The routes are there. Good so far? So again, what is the stage that you do it? CE goes into the VRF. This is your PEC routing protocol doing it. From the VRF into the VPN v4 table is the redistribution. Now, what do I do to get the route from this PE router to the other PE router? Export is your route target, which is already on the route. So if I see the route over here, the export RT will be attached to the route. Okay, I need to run MPBGP to get the VPN v4 route over there. I've done that. Import is from VPN v4 to where? Into your VRF. I should at least see it over here, right? Yeah, you won't see it in the VRF on the other side. Should you see the VPN v4 device over here? Now let's take a look at this. This is what I want you guys to see. By default, when you go over here, I would have received the route, by the way. I would have received the route in the VPN v4 table of R4. Send community extended in the newer iOS is a default command. So although I didn't type it, but if you do a show run, you will see the command there. Show run section router BGP. See this? It's a default command now. So what happens is when you get the route into your router 4, the PE router, the route would have arrived on the VPN v4 table. But then what happens is it checks the local VRFs to see if any route, any VRF has an import route target that matches the route. That means one of my VRFs requires a route. And right now I don't have any VRFs where on R4. So when the route was received over here, it will receive it, but because there's no import RT, it would discard it. No point holding on to the routes. You understand that? This is a default behavior of MPBGP. So if there's no local VRFs that have any import route target, that means this route is not of any use to me. I will actually discard it from my VPN v4 table. But there are certain points, certain type of things that might require you to have the route in the routing table. When we do the inter-AS MPLS VPN, one of the options requires it. So I need to have the route in that local VPN v4 table so I can propagate it across in some cases. Here, I would have done the VRF later on and you would have seen the route. But I want you guys to see this so that you have this in mind so your knowledge is at a different level. So if I go over here again, I'll do that alias exec command, alias exec svpn show BGP VPN v4 unicast all. It will drop it if the RT is no RT, that is no import RT on any of the VRF, so it'll drop it. Okay. So now if I do show SVPN or SVPN, it won't see any of the routes. Why? I discarded the route because there was no use to keep it. But as I said, in some cases, you might need to have it. So can you configure your router to accept the route, keep it, although you don't have a VRF for it? There are use cases for that, and you will see that tomorrow. Okay? But for right now, I want you guys to see it's not there yet, but if I do want that route to be there, I go into my BGP process, no BGP, default route target filter. This is the command that's on by default. BGP default route target filter is on. This is the route. This is the command that discards the route if you don't have an import RT matching any of the VRFs. Understood? So now if I do show VPN, give it some time, clear IP BGP asterisk soft. There you go. Now I see the routes there, although I don't have an import route target. The reason for that is I disabled the route target filter that does that for you. And it is a requirement for certain situations. We'll talk about that when we get to that tomorrow, but understand this is a known behavior. So keep that in mind when you're troubleshooting. Everybody understand the problem and why I would discard a route? You guys okay with this? All right, so I'll get rid of the command. I just want you guys to see it there. It is normally a good thing to do this. So I should not see the command, the routes over there until I have some type of requirement for it. So it's gone. Understood this, guys? Everybody okay with this? So at this point, what has happened is I'm ready. This part is good. This part is good. Even this part is good. You verified that because with the BGP route target filter, you saw the route over there. Now let's configure this side. When I configure this side and I configure the VRF over here on R4 and configure the customer route over here, I should be able to receive the route because my import RT now will be 1:1, which matches the export RT for the other side. And that would automatically take the route into the VRF. Good so far, guys? Everybody okay? So let's just do the same thing that I did for what? R5 to R1. Let's do the same thing from 4 to 8. Let's configure 4 first. That is this step over here. So I'll just copy this part over here and then change it for R4. Same VRF, same RD. But what about these guys? Export should be 1:2, import should be 1:1. You guys remember that? He's exporting 1:1, so I should import 1:1. He's importing 1:2, so I should be exporting 1:2. Everybody okay with this? All right. Assign the VRF to the interface. Here, the interface is E02. So E02, and I'll keep it as 192.1.48.4 and .8. This is E02. This is good. And what's the protocol over here? OSPF. Now, OSPF as a protocol, when you run it as a PEC protocol, the way you do that is router, OSPF, and a process ID. And you attach the process ID to the VRF. There's no address family per se. So this process ID is dedicated for what? Class A. That's how you do OSPF. Understood? So let's do the OSPF process over here. Let me show you how. So there's no address family part in OSPF. You do OSPF, let's say 2, VRF class A. There's no auto summary, no version. Network would be 48.0.0.0.0.255 area 0, and that should be it. And then I would redistribute BGP into it. Keyword subnets. That's how you redistribute into OSPF normally. So I'm redistributing BGP into OSPF. So the routes that I learned from where? The other MPBGP route, which is the route from R1, I'm going to take the route and propagate it to my CE router by redistributing it. And BGP, I'm going to redistribute what? OSPF 2. Understood? So again, the mutual redistribution between PEC protocol and BGP. So that would take care of my R4. Now, because R4 now does have an import RT that matches the other side, now that route will be accepted. So if I go to router 4, configure it. Looks like it took it. Give it some time. And there you go. I'm receiving 10.1, 10.5. And if I check my VRF over here now, because of the import RT, I would have gotten the route into my VRF as well, but it's a what type of route? It's a BGP route because I learned it through BGP. So in our case over here, the process is I received it from RIP. There's a RIP domain, which is getting redistributed into what? BGP. And then BGP, this is R1. This is the VRF. This is VPN v4. This is R4. BGP is VPN v4. And also in the VRF, it's a BGP route because BGP is running from where to where? From this guy all the way till here, it's BGP. Even the VRF, I will receive the route as a BGP route. But the next leg over here is what? OSPF. That requires redistribution, which I have also taken care of. I will do that once I finish. Not right now because the routes are not there. I don't have. Can you do a trace route from R1 to R4? I did that already, right? Initially. So now let's do 8, similar to 5. 8 E00 is 48.8. Loopback, I have 10.2, and I have 10.8. My routing protocol is router OSPF 1, and my networks are 48.0 and 10.0. Let's do 8 now. If everything's fine, I should establish a relationship with my PE router running OSPF as my PEC protocol. And if I do show IP route for the routes received through OSPF, you see 10.1 and 10.5 received as what? As OSPF routes, because they were redistributed by the R2, the R4 router, the PE router. Good so far? Can I reach it? Ping 10.1.1.1. We'll do it from 10.2.2.2. What do you know? So now I have reachability all the way from R8 to R5. Now let's analyze this packet carefully. Let's actually do it from R5. I'll do a ping from R5. 10.5.5.5, or sorry, 10.8.8.8, source 10.5.5.5. I'm on R5, pinging R8. It is successful, but I want you guys to work like a router with me. 10.5.5.5, 10.8.8.8. Understood? Isn't that the packet? When it creates a packet, I want you guys to see the path. So it sees the destination as 10.8. What does it do? It checks the local routing table. Where do you see 10.8? Over here. Via what? 15.1. So who does he send the packet to? Who's 15.1? You guys have the diagram as well. 15.1 is the PE router. PE router receives it in the VRF. So let's check the VRF and see what he sees over there. Show IP route VRF, cost A. How do I reach 10.8? Again, it's checking the layer 3 header. What does he see over there? Why 4? Because my BGP neighbor relationship that was used to exchange routes from R1 to R4 was set up based on what? 4444 and 1111, which is critical. Remember, I explained to you guys if I did not do it, my PHP would happen in the 4. So it has to be based on the loopback. Now, because of that, it'll go and check the next stop. It does a recursive lookup. Says, oh, this 4 is in my global routing table. Through MPBGP, checks the MPLS forwarding table, and what does he see over there? What's a label that I need to use? Ah, I shouldn't have deleted it. Okay. So 10.5 going to 10.8. What does it check over here? Reach 4, because the next hop is what? 4. Label, outgoing label is 18, correct? What's a label? Forwards it to whom? This guy, correct? Everybody okay with this? R2 receives it as a label packet. because it receives it as a label packet, it's going to check the LFIG. I'll get to that, Gregory, one sec. Outgoing label 18. Oh, sorry, incoming label 18, outgoing label 18. So receives it as 18, sends it to what? R3. R3 happened to use the same label for network 4, forwards it again. It actually does a swap. So takes 18 off and puts 18 back on. Forwards it towards R3. Understood? So R3 receives a packet with a label of 18. What does R3 do with the label? 18 will pop the label. Good so far? But again, although it pops it, it doesn't do a check on it. It doesn't do a layer 3 check. It pops it and forwards it to whom? 34.4, but as an IP packet. Now, when it sends it to R4 as an IP packet, there's an issue over here. What is the issue? When I receive the packet over here, what interface do I receive it on? E00, right? I receive it on E00. E00 over here is what? It's in the global routing table. The global routing table has no idea about 10.8. But the ping is working, right? I showed you. So why is it working when it would have received it on R4? This is what happens. MPBGP is aware of this issue, or the working of MPLS over here. So what he does is, at the time he is doing the control plane propagation, when he sends the route 10.8.8.0 to whom? To R1. He told him, hey, listen, when I'm sending you this route, please use a label to send the route to me, whatever label it is. Let's say 31. So that label is not generated by LDP. LDP just provides a label for what? Forwarding the packet to the MPLS 4. This label is generated and exchanged by MPBGP for every single VPN v4 route. No, not IGP. It is generated by MPBGP. What am I running between R4 and R1? It is MPBGP. So MPBGP assigns the route that is exchanging or sending towards R1 a label and tells him, hey, listen, when you send me a route, or sorry, when you send me traffic for 10.8.8.8, please set the label to 31. So initially, when the data packet had come in, and that's what Gregory was alluding to, the outside label, yeah. No, it would not be generated by IGP. It would be generated by LDP. Right? For the IGP route. Yes, Jamel, it's the VPN label that Gregory was talking about. All right? So he would have a label for 10.8. So when the packet came in, it looked like this. 10.5 going to 10.8. First thing it would have done, as soon as the packet would come in, it would have assigned it the label of what? 31, which is your VPN v4 label. This label is only known to R4. These two guys don't know about this VPN v4 label. Understood? It is using the same bucket, yeah. It's from the same 1 million. So essentially, you are out of labels when you're doing MPLS VPN. Route lookup has nothing to do with the data packet. The purpose of route lookup is just for the control plane propagation of the route. It does not come into the play for your data propagation. You're mixing the data and the control plane. Route target was there just so that my route was put into the appropriate VRF. That's where the route target's functionality finishes. I don't do a route target lookup in my data plane forwarding. Route target is just to propagate the route from routing table to routing table, from my VRF to the VRF. When the data comes in, route target is, it's done its job, it's sleeping at that point. Get my point? So this is the VPNv4 label. Then it did the thing that I told you about, the 18. So the 18 label that you guys saw is this label, the outer label. This is the LDP label. So when he was doing the swapping, this was done, the swapping was done on the top label. The bottom label was untouched by this guy. When the swap took place, it swapped it from 18 to 18. From here, he popped what? He just popped the top label, the LDP label. So when he received the packet, over here on this interface, it was still a labeled packet. So once it comes in, because it's a labeled packet, it'll check the LFIB. The LFIB would say, hey, listen, this particular packet coming in with 31, and I don't know what it is, but I just made 31 up, should go to this particular interface, this VRF. So the responsibility of the VPNv4 label to take the route that was received on the service provider side interface and put it into the appropriate VRF. You guys understand that? It is set by the ingress PE, which is R1 in my case when I'm sending the traffic, and it gets popped by the other side. You can see that in your trace route, by the way. If I went to R5 and I did this, the only thing is on Eve, it doesn't do a proper trace route, but I'll still show you some part of it. Actually, this one is good. See these two labels that you guys see over here? This 18 is the one that I was talking about, it pops it. And what is on the leg between 3 and 4? Do you guys see this? This 22 label? This is that VPNv4 label. So even on that leg between 3 and 4, it is still a label packet. Can you see this label? Absolutely. So on R4, I would have sent this label. So if I go to R4 over here, show BGP VPNv4 unicast VRF cust A 10.8.8.8. I want you guys to see that it is exchanging the label. This is the incoming label. Incoming label means the label that I'm assigning, 22. Remember that 22 that showed up? That's the 22. If I recall, 18 is still locally significant. Yeah, it is. But when I send the packet to the other router, he's also using the same label. So it swapped from 18 to 18. Got it, Gregory? It just happened to be the same number. That's why yesterday I did 100, 200, or 1,000, 2,000, 3,000, because I wanted you guys to see it. Otherwise, it would be the same. The VPN label is different. Oh, if you run the route from the other CE, means from, what do you call it? 10.8 to 10.5? Is that what you meant? Yeah, it would be a different label because the destination in that case would be the label for 10.5. Just a marker, yeah. Just a alias for it. As I said, I think somebody asked a question earlier on. It's always unidirectional. Not necessarily, Stein. Yeah. So now, just to finish this off, so this is my incoming label for 10.8. On the other guy, this will be the outgoing label, because he's going to use this label as the label to send me. So if I go to 1 here and check the same label, same route, basically, BGP VRF cusp A 10.8.8.8. What happened? Show VPN, show BGP, VPN v4. Flipped it. Come on. See this? It becomes that same label 22. This is my outgoing label. What was the incoming label here becomes the outgoing label on the other side. You guys understand this? Everybody okay with this? I wanted you guys to see the inside of how MPLS works. So any type of misconceptions that you guys have, you can see it by looking at the traces, looking at the routes, seeing the labels and all that. Good. So that takes care of this one. Yes, Harry. Yes, there is a possibility, especially with FRR. How does a data path? What do you mean by data path? When the packet comes in over here, he's the only one that needs to know about the data path, right? These guys don't, because they're just doing the swapping of the LDP label. Is that what you're pointing out to? Yeah, but the labels that are assigned, who assigned the label over here? Who was responsible for assigning the label for 10.8? The PE was. When he assigned the label for 10.8, he knows that 10.8 is in this VRF. So that's where he assigned that VPN v4 label. So the label is the one that was assigned by R4 when he was sending the route across to 10.8, which is part of VRF, whatever VRF it is. So if you go over here, actually I need to, because I've been doing the label, my friend, label. I'm not looking at the route when the route packet comes in. I'm looking at the VPN v4 label. Again, when I go to R5 and I do a trace route, here, what is the label coming in? Is it a label packet or is it an IP packet on R4? It's a label packet. So do I check my routing table or check my label? I'll check my label packet, right? LFIP. So on R4, show MPLS forwarding table. Incoming label, local label is 22. No label. Don't send it as a label packet. It's a VPN v4 label. Send it to E2. E2 is part of the VRF. And I assign that 22 when I send him the route. I'm the originator of that label, so I know that it's coming from this particular VRF. I do a label forwarding on that PE router. Got it? So this route that I have, show BGP, VPN v4, unicast VRF, cust A, that is the LFIP, correct. 10.8.8.8. When I send this route out, I know this route 10.8.8.8, this particular one, is in this VRF called cust A, and this is the one that I'm going to assign 22 to. The other, let's say 10.8, not even 10.8, I have 10.2s on both sides, right? Let's take this. I have a duplication over here, 10.2 and 10.2. When 10.2 comes into this router, into the VRF, and I assign it a label, I won't assign it 22. I will give it a unique label for that 10.2. So these two 10.2s will have two separate unique labels. 10.2 from green will have a different label. Let's say label 29 or 27. The 10.2 that's coming in from here had a label of 22. This would be unique. So because the PE router is doing that, it would have unique labels for both the 10.2s. So, and it puts it into the LFIB. That's how it knows. When the packet comes in, it's a label packet, not an IP packet. All right, let's go ahead and do this part now. At this point, just to recap, how much have you done? Review is done. PC routing protocols, we've done RIP and EIGRP. No, we've done EIGRP and OSPF. Let's do these two now, and then we'll take a break. EIGRP and BGP, and then we'll take a break. So EIGRP 111 on cust B and BGP on R7. Okay, so how do I do EIGRP now? Same thing, but now I'm doing it for 1, 2, 3 is common. Now R1, I'm going to be doing the other VRF, which is cust B. Up until now, I had done cust A. So cust B now, I need to do the same type of thing. So I'll just copy this. For cust B, VR definition, I'll call it customer B, different RD value. And this is normally the case. This is what you should do so that you don't need to worry about too much about the RT. I matched the RT and my RD value, so I don't need to remember too many things. But I wanted to purposely do that flipping of the numbers so that you don't have in your mind that they need to match. Good so far, guys? Everybody okay with this? Now, the interface on this guy is E02, which is 192.1.16. I'm going to run EIGRP and 111. So E02 cust B 16.1. This takes care of that. PEC routing protocol is EIGRP. Now, EIGRP, I am already running in my core. Show run section router EIGRP. It's running 100. This is part of my core. What I'm going to do is for all my customers, if they're running EIGRP, I am going to run it in, let's say, EIGRP 1. But the other guy is running 11. But the AS number for my CE router is not defined here. It is defined here. You get my point? So this is just like a process ID within which I have an address family B, autonomous system 111. This is the autonomous system that the customer edge router needs to be running. Good so far? And this part is the same. 16 metric. EIGRP uses those 5 metrics: bandwidth, delay, reliability, load, and MTU. Anything doesn't matter, as long as you put a number. And BGP, I am going to do the same thing. Cust B, I'm going to redistribute EIGRP 111. Turns out RTRD, I have read different. It's better, it's easier to keep it the same. You have less configuration issues that you have. When you mix and match them, it becomes an issue. You only want to change it if you have the ability, which I'll be doing over here, doing extranets. That's where I would do selective changing of the RTs. Try to keep it simple. And most of the ISPs, they have like a cookie cutter system. I've taught classes at different service providers. They didn't even know that the RD and the RT values had to be different. They thought they had to be, sorry, they could be different. They thought it had to be the same, because they're just doing copy paste type of configuration for all the customers, and they've been told that they have to be the same. Just to give you an idea. So that's what people have been doing, so most of the time. So now I'm going to redistribute EIGRP into BGP, and my first router over here should be okay. Copy. E02. So this part is done. Now let's do the CE router, which is R6 over here. R6. I love Notepad. 6.6, and this one also has 10.1, so that I can show you a conflict, and 10.6. This guy's running EIGRP, so EIGRP 111, 16, and 10. Let's go to 6. Move back up, Ethernet up, my neighbor relationship should come up. So now R1, show IP route, VRF, cust B, has those routes. Show SVPN, that's my alias thing, 10.1 and 10.6. Good so far, guys? So EIGRP is also done. You guys understand how to do EIGRP as well. Next thing, BGP. That is correct, Jamil. As long as the AS number matches, it's good. Doesn't really matter. Now, last one, or not last one before the break is BGP. I'm running 65001 over here as the customer's, what do you call it, AS number, giving a private AS number. This is the most common protocol for PECE. Why? You don't need to do redistribution, because I'm running what? BGP over here. I'm running MPBGP over here. When the route comes into my VRF as a BGP route, it automatically goes into MPBGP, and vice versa. When the route came in from here, it's automatically going to go down over here. There are certain issues that you need to be aware of with BGP. We'll do them after the break. But for right now, basic configuration, get it up and running. So let's go to router. Oh, actually, I'll do it over here. Now my other customer VRF for B. So this is B on R4. And this was A. So B, this part is okay because I use the same numbering. Interface I need to check. This is E01 47.4. So E01 cust B. This is 47.4. This is BGP. So the normal BGP that I run, 100, address family IPv4 cust B, and BGP is based on neighbor commands. So my neighbor over here, neighbor 192.147.7 remote AS, we'll call it 65001. That's it. I don't need to do any redistribution, nothing like that. That's what makes BGP much better. The whole purpose over here is that it is an MPLS VPN connecting two different sites belonging to the same customer to each other. But now, the thing that I told you about, BGP does have some issues if you have the same customer having the ACE numbers that match and all that. We'll do it after the break. But let's do a simple one for right now. So now I know that my R7 is going to have an AS number of 65001. Copy. Let's go to 4. 4. There you go. Done over here. And now 7, the only one missing. This is the PEC BGP, so it could be different. It could be the same. It's inside the VRF. Within the VRF, so you can do whatever you want. So this is R7 now. This would be E00 47.7. Loopback I have is 10.222 and 10.777. This is BGP. Neighbor 47.4. Remote AS is 100. The network that I have is 10.2.2.0. Mask is that, and I will just copy this and make it 77, and that would be my BGP. The good part about this is I don't need to do any redistribution or anything like that. It should automatically come up. Let BGP pop in. As soon as BGP pops in, I'll get the ROS from the other side. Show IP BGP. 10.1, 10.2, 6, and 7. That's what I wanted to connect. 10.1, 10.2, 6, and 7. So again, this guy also has reachability now to 10. Let's say 666, source of 10.777, or I can go to, let's say I'm 10.2.2, go to 10.1.1 on the other side. Good, everybody? So that's BGP as well. We'll do a little bit more with BGP when we come back, but if you take a look at it, basic setup of BGP is also done. So we're over here right now. Good so far? All right, so this part is done. I want to bring up a diagram that I have that I would like you guys to use, which is a nice one that I've created. Let me see where I can pull it up from. Oh, put it into your folder. Take a look at this diagram. Open it with photo or something. This is a diagram I have to help you do troubleshooting. Now, when you're looking at this diagram, look at it from the perspective of going from taking the route. This is your control plane from left to right for troubleshooting. This is one PE router. This is the other PE router. Okay. As I've been talking about, when I get the route, it goes from the customer router to your VRF. What if the route does not exist over here as a troubleshooting thing? What do you need to do to make sure that my route has propagated from point A to point B? What takes a route from the CE router to the VRF? No, that's later. The route's not even coming into your VRF at this point. You've done it, you check, right? Verify what? This is running. No, not unicast routing. I'm doing it between what? CE to the PE. I'm running a PEC routing protocol. PEC routing protocol. Is RIP running properly? Or whatever your route, no, not route distinguisher. Understand. I want to take the route. I want to see if the route has been received on the VRF. The only thing that I need for that is the provider edge, customer edge routing protocol to be working properly. Whatever routing protocol is it, whether it's RIP, PIGRP, OSPF, BGP, whatever you're running, make sure that is configured properly. So if you're not configured that properly, you won't see the route over here. Understood? Even the RD value would come in from where? When you go from here to here, this would require your RD value. That's the next step. And I've color coordinated that. The red over here is what? If this, you're not getting the route over here, that means there's something wrong with this because this is the component that makes it possible. Understood? Again, left to right. Once the route's inside the VRF, what's the next place that you want to put it into? You need to put it over here. That's where the RD comes in because it needs to be what? A VPN v4 route. And if I'm running any routing protocol other than BGP, what do I need to do to get the route from what? 1 to 2 was PE, 2 to 3. It should be redistribution, except not required if the PEC protocol is BGP. Not to the LFIB Ernie, to the VPN v4 table, the 96-bit route. LFIB, the labeling comes in at the point of data path forwarding. I'm not doing data path forwarding. I'm just checking the control plane, the routes. Are the routes in the proper place or not? Understood? This is just for whether the route has been propagated in the routing table or not. I'm not talking about labeling over here, just the redistribution of the, or taking the routes, propagating of the route. Everybody okay with this? You guys understand this? So the first place is what? From 1 to 2, which is because of your PEC routing protocol. From 2, the next place is your VPN v4 table. This is done through redistribution. Now it's on the VPN v4 table over here. I need to get to the next stage, which is 4. 2 things to check over here. Number 1, is your MPBGP configured between the 2 devices? Number 2, you should also check is what? Import RT. Do you have a VRF with the appropriate import RT? Because if you don't have the import RT, it would make it over here, but it would get rid of it. You guys remember that? No BGP. So it might not be a bad troubleshooting command. Default route target filter. Put it in, so put the no in, so you can at least see whether the route's getting propagated or not. So if you're seeing the route over here, but not over here, what does that mean? Something wrong with the import RT, because import RT is the one that will take the route from the VPN v4 table into the appropriate VRF. All right. If it's in the VRF, it's going to be a BGP route, and you're not seeing it over here. What's the problem? The BGP route, you're running what? Non-BGP routing protocol, so you again need to do redistribution. So you need to do redistribution in how many places? 2 places. Redistribute from the VRF into the VPN v4 MPBGP, and then from VRF to the CE route. Good. What I've done is just shown you how to do it from where? Left to right. You need to repeat this. Let's say this was going from R5 to R8. In our case, you need to repeat the same process from what? 8 to 5. So again, start. Do the same in the reverse direction. And that's why they recommend that you use what? BGP as a protocol, not just for the configuration issues. It's also the processing that it takes. You have multiple VRFs that you're redistributing into BGP. So it saves you on the processing of the routes on that P router as well. If anyone you guys is taking the CCI route switch or service provider exam, very useful diagram that you can use. Good? Fun stuff, isn't it? All right, so let's go ahead and take a break. It is based on this clock, 12:20. Let's take a 15-minute break, 12:35. We come back, get my tea, get that energy. 15-minute break, we'll come back, and we'll take a look at the other stuff. It's 12:20 at night, man. I'm in Delhi right now, New Delhi. All right, guys. Hello, hello. You guys back? Let's get this back over here. The next thing I need to talk about a little bit more is BGP. The most common PEC protocol. Why is it common? The service provider mandates that the customer run this link not as RIP or EIGRP or OSPF. They generally mandate that they run as BGP. By doing that, they're avoiding the redistribution load on the PE route. So generally, the customer enterprise would run some type of IGP over here, whether it's EIGRP, whether it's OSPF, whatever the protocol they're running over here, and have them do the redistribution. So when they send the route over here, it's a BGP route. That way, I don't need to worry about the redistribution over here. Correct. We don't need to do any redistribution. The route comes in, and there's less issues of configuration problems that might happen. But at the same time, you also need to keep in mind that when you're doing this for the customers, the customer might say, I don't want to run BGP because I don't have an AS number. So what you do is you give the customers the same AS number, let's say 65001, and there's two different ways of doing it. This is a private AS, by the way. This is the other customer. He might also, he's part of the same company, so he might also get the same AS number. So you don't need to give too many AS numbers. For every customer, you give a private AS, and you can reuse the numbers because they are running within the VRF. But the problem over here is when I receive the route from him, the route's going to have an AS number of 65001. Not a problem at this point. I send it over here, it'll still have 65001 as the AS number. But when the PE router sends it to this guy, if he's also configured as 65001, this guy, using the normal BGP rule of not allowing the same AS coming in from outside, any route having the AS number that you're using coming in from the outside, it would have dropped it. That's the issue that you have with running BGP. So what the service providers do is when they're sending the route towards the customer edge router, they use a special attribute for the neighbor. That attribute is called AS override. What happens over here is when I'm sending the route over here, generally it would have sent it like 100, which is the AS number for the service provider, and 65001, the originating AS number. What the service provider does by using the AS override, he replaces the original AS number by putting in 100, 100. So he's not receiving the route as 100, 65001. He receives the route as 100, 100. And that problem is avoided because the customers, it's not a loop because these are customer sites using the service provider MPLS backbone to talk to each other. All right, you understand that? So that's how they avoid that issue. Let's do that between, I'm going to change it, not run RIP and OSPF on these customers. I'm going to run BGP on both sides and give both of them 65001 as the AS number. Let's see how that works out. So now I'm running over here. I'm going to running BGP as the PEC protocol between CAST sites. That's my requirement. So let's start with getting rid of the older what do you call it, PEC protocols. On R1, I'm going to say no router RIP. That should get rid of RIP over here. And on R4, no router OSPF2. At the same time, I'm also going to do it on R5, no router RIP. And on R8, no router OSPF1. That should get rid of my PEC protocol completely. Okay, so now let's go ahead and do the customer routes first. C routers, R5. I have the IP addresses set up, so the only thing that I need to do is BGP 65001, network 10.1.1.0, mask is this, and network 10.5.5.0, mask is this, neighbor is 15.1, remote AS is 100. Let's see if this works. R5 looks good, and the other one is R8. I want to keep the same AS number. It says 10.2 and 10.8. The address is, if you look at your diagrams, 48.4. This is R8. Done. Now, how do I do it on the C routers again? R1. Router BGP 100. Address family IPv4 VRF cast 8. Neighbor 192.15.5. Remote AS is 65001. That's it. On R4, it is going to be, and because it's the same customer, I'm not changing the AS number. I'm giving both the sites the same AS number. So on R1, run BGP, should come up. Let it come up and then we'll move. Come on. There you go. And then R4. Let this come up. So now, if you take a look at your VRF, I see all four routes: 10.1, 10.2, 10.5, 10.8. So the SP's BGP number 100 is managed by SP, and SP will assign these customers a private AS number. So for all of them, they're communicating to the SP, which is 100. Is that what you're asking? Okay. So SP's AS number is 100, but SP is the one that's going to assign these customers a private AS number so that they can do this MPLS VP. Now you can see on R4, I have all four routes. You can see on R1, I have all four routes. And all of them are BGP routes. But the problem is R5 does not see any of the BGP routes from the other side, and R8 does not see it. Again, the reason for that is that loop avoidance technique. Now, there's two different ways of getting around that problem. Solution number one. The provider edge router overrides the private AS with its own AS number. So the loop would not be there, or it would not see it as a loop. So we'll do this from one side to the other. So if I want to do this solution on the PE router, I use this AS override keyword on the PE router. So I'm going to go over here. Let's fix it on this way using the AS override. So on R4, I'm going to say whenever I send a route towards R8, I'm going to override the AS, which was supposed to be 100.65001. I am going to replace the 65001 with my AS. So the AS path now that CE will see is 100. That will not discard it. Understood? So how do I do it? I go to router 4, router BGP 100, address family, IPv4, VRF cast A, neighbor 48.8, AS override. Here IPBGP asterisk soft, and what you will see is the route came in and it has the AS number as 100. This is the recommended way of fixing it because generally this enterprise customers do not have too much knowledge on BGP. The understanding is not there, so the service provider fixes this problem. Okay, there is a way if you want to fix it at the customer edge router side as well, and I'll show you the other option. This is generally not the one that people use. So on R4, I did what? Router BGP 100, address family, IPv4, VRF, class A, and in the neighbor, for the neighbor command, I said AS override. All right. Solution number 2 is done on the customer router. So generally, if you're taking a CCIE exam, they'll say, don't do it on this router, do it on that router. That's what they really mean. The CE router disables the AS or allows the route to come in even if the AS path, even if its AS number is in the AS path. The AS override, Jamil. The second one, not very commonly done because, again, as I said, not a lot of expertise for BGP at the enterprise level. So on router, this is a C router. I'll do it on R5 because we've taken care of it on the R4, R8 leg. So from this side, I still don't have the routes. So if I go to R5, I still don't see 10.2 or 10.8. Yes, this disables the BGP loop prevention mechanism for that particular neighbor though. Not completely, just for that neighbor. From that particular neighbor. So, because it's a single link to the service provider, it's not as dangerous, but I would still stay away from it, try to do the AS override. That's a more common way of doing it. Got it, Jeff? Yeah, but sometimes, Bill, what happens is these are managed services routers where the service provider is also managing the CE router. So over here, how do I do it? On R5, I'll say 65001, address family, IPv4 15.1 is my neighbor. Allow AS in. So right now I don't see it. Oops, yeah. I don't have this. Sorry. Show IPBGP See, now I have 65001 coming in as is, although my AS number is also the same. These are the two common ways of allowing this route to come in. Again, as I said, the more common one is solution number one. Good, everybody? Now we have two customers over here. I have the purple customer, cost A, and I have the green customer, cost B. What I want to do is I want them to communicate to each other. These two customers maybe are sister concerns that do want some part of the network to talk to each other. So what they want to do is they want to allow this common network to propagate through. Which common network? 10.5, 10.6, 10.7, 10.8. I want them four to talk to each other. I would stay with the one. There's no security implications on it. The second one can get dangerous if you have like a backdoor and, or something to that effect. Whereas this, for the first one, is easier. Consolidated, merger, those type of things are happening. All right. So I want 10.5, 10.6, 10.7, and 10.8 to talk to each other. Okay. So I do want to leak out the 10.5, 10.6, 10.7, 10.8 routes to each other, but I want to keep them other routes which can be conflicting within their own customer. Leaking the routes. This is known as an extranet. Why is it called an extranet? Because you're connecting what? Two different companies, two different VRFs to each other, also known as route leaking, if you want to call it that. How do I accomplish this? Now, the way I accomplish this is by using the route targets. This is the use of route targets. This is why you wanted to make they wanted to keep a different value for allowing the route to come in and out of a VRF rather than just using the RD value. RD value was, as I told you earlier on, what was the purpose of the RD value? The main purpose of the RD value was to make it unique, right? Unique 96-bit route. The RT value was the one that was allowing the route to go in from one VRF to the other. Now, the way I'm going to do it is this. I have my normal VRF RT over here as, I believe, 1:1 as the export. I haven't changed that. And this part is saying VRF RT is 1:2 as export. Agreed? He's importing what? 1:2. And he's importing 1:1. Agreed? This is for all routes at this point. Understood? What I want to do is I want this route, 10.5, only this route, to have a separate RT value. I'm going to assign it an RT value, let's say 100:99. I'm going to use this RT value 100:99 as my route target to exchange the routes between the two different VRFs. So although I have a common RT and RT export and RT import for my routes, for the routes that I want to leak out, I want to give it a separate RT value. And once I give it a separate RT value, I am also going to import this in here. So I'm exporting this, but only for a specific route, and importing anything that has 100:99. I am going to do the exact same thing with the 10.6 route over here. What am I going to do with the 10.6? I'm also going to allow 10.6 or assign it a RT value of 100:99. And in this VRF as well, I'm going to import 100:99. So that would get me the 10.5 route, and the 10.6 route will be imported over here. You understand that? So for a specific route, I have the ability to specify what? A separate RT value. Everybody okay with this? So let's take a look at the situation over here. Route leaking, whatever you want to call it, route leaking, extranet situation. Or we'll call it a configuration. Requirement 10.550, 10.660, 10.770, and 10.880 should have reachability from all cast A and cast B sites. That's my requirement. Okay, so how do I do it? On R5, I'll create an ACL. Step number 1, configure an ACL to classify the routes. I'll start with, let's say, cast A on, not R5, sorry, R1. So for cast A, classify the routes. Classify the route that I want to give this special route target to. So that, in my case, the one that I want to leak out is permit 10.5.5.0. Agreed? Business to business, absolutely. Or merger, or migration between two different sites that were initially two different sites, but now I want to do it. Reachability. Should have, yeah. Reachability from all customers. Thank you. Yep, that's what I meant. Number 2, configure an ACL. Number 2, configure a route map to call the ACL and set the RT for the route, for the network. So what I'm going to do is I'm going to call it route map. EM stands for export map. That's what I'm doing. And I'm doing it for cast A. MAC IP address 1, set extended community RT, set the route target, because our route target is an extended community, 100:99. Is that what we agreed? Pick a number that's not being used. Okay, once this is done, I'll go into my VRF, configure the VRF to use the export map and import the common RT. How do I do it? VRF definition, cast A, address family IPv4, and in there I'm going to specify my export map as EM-cast A. So basically use the export map EM-cast A, which says if any route matches ACL1, which is 10.550, set the extended community to 100:99. Good. And then besides that, I also want to do the normal route target import 100:99. I can have multiple imports that I have. I have the 1:1 or 1:2 from the other side. Besides that, I'm also going to import 100:99. That's not for 10.5. That's for the 10.6 or 10.7 or 10.6 and 10.7 that will be coming in. Or later on 10.8 also, because I'm also going to set 10.8 to 100.99, the common one. So let's do this over here for custom on R1. Let's go to router 1. Looks good. No, when you do this by itself, like when you say set extended community 100:99, it is just going to set 100:99. So it overrides the 1:1. But if you did want to maintain 1:1, maybe there's other sites that I've not written over here. Maybe there's a site hanging off over here. He's just importing what? This is also a site that belongs to a purple over here. There's another site over here that belongs to the same customer, cust A. And this has nothing with 10.5, 10.6, 10.7. I just want normal route. So he's just importing what? 1:1. He does not, I don't want him to get what? 10.6, 10.7. So in that case, what you would do is you would maintain the 1:1 and add 100:99. In that case, you would have 2. But in order to do that, if you want to maintain both tags, in that case, what you would need to do over here is you would need to add a keyword called additive. If you do that, it'll maintain 1:1 and add 100:99. But if you don't put the keyword additive, it overrides. So it's only going to have one route target. Good. You can see it now. If I do show BGP, VPN, v4, unicast all, correct, absolutely. VRF, cust A, 10.5.5.0. You will notice it still has this, so I need to clear it. Let's see if the ACL is getting hit. Yep, it's got a match. There you go. See that? Only one. So it replaces the 1:1 with 100:99. All good, guys? Everybody okay with this? All right, so let's do the 6 now, which is cust B. So create another ACL, ACL2, which will have 10.6, the one that I want to leak out. I'll call this export map, what do you call it? Cust B, match ACL2, which is this guy, 10.6.6. I'll set the same RT because I'm importing it into cust A. And then I'll go to cust B. This is 2, cust B 2, same one, 10.6. This is fine. We'll call this guy and do the same. So this would take B into the 10.6 from B into A. Copy it. We'll go to I. All right, show IP access dash list. We have 2, clear IPBGP asterisk soft. There you go, there's a match. That means it has been used. And it has been used, so show BGP, VPN, v4, unicast, VRF, cust B. And I'll check 10.6. 10.6 should have a 100:99 as the RT. There you go. All right, and to see the result, if I go to router 5, show IP route, BGP, I have 10.6 now. And if I go to 6, show IP route, I don't know what I'm running over here. I'm running EHRP. I have 10.5. So I've leaked it out from what? A to B, but only that 10.5 route. I still need to do what? 7 and 8 over here. How would I do it? How would I do 7 and 8? Not 7 and 8. I would need to do it on R4 for 7 and 8. Same concept. I'll just copy paste it and make some changes. R1 was done. Where's R2? This is R4. So R4 class A, the network is 10.8 that I want to replicate. Same concept, same everything. So this guy looks good. And for, let's do A first, get that out of the way. So all I did was change the ACL to 10.8 and everything else remains the same. Copy it, go to R4, paste it, show IPBGP asterisk soft. Now there will be a slight issue over here. What is a slight issue? If you guys remember, I'm also running what? These guys are also running. These guys won't have an issue because I fixed it between R5 and R8. R7 I haven't fixed because R7 is still running 65001. So what do I need to do on R4? In our situation over here, show BGP, or sorry, router BGP 100, address family IPv4 VRF, cost B, neighbor 47.7 AS override. Otherwise, he would discard that route. So let's check now. 10.2 and 10.7. Okay, 10.7 is coming in. The other guys will come in as well. 5 and 6 will come in eventually. So at least 10.7 now is coming in. No, 10.7 is itself. 10.1 and okay, it's not there yet. It should eventually come in. Oh no, not yet, not yet. Why not yet? Because I'm not importing this guy yet. But eventually it will. Cust B. The route that I want to set it to is 7. This remains the same, this remains the same, everything else remains the same. Just change the route. So now do this on 4. Try PBGP. Not over here, sorry. Over here, show IPBGP. There you go. 5, 6, 7, 8. Becomes tougher? Absolutely can. Absolutely can. It's just working with the RTs. Understood, guys? Everybody okay with this? This is the export maps. So now if I go to 5, I should be able to go what? From 10.5 to 10.6. And 10.7. 10.8 is my own site from the get-go. So that would always be there. So now I'm doing cross VRF communications. From here, here. Set RT number can be different, meaning I could set different RT value over here as the export for 10.5. Yeah, that's true, but then you would need to import different numbers at different places. By doing what I did over here, I minimized the number of imports. So because I wanted these 4 routes to be the common routes, I set a common RT for them and imported it just once. Otherwise, let's say I had done this for 10.5. I would have said 100 colon, let's say 11. So over here, I would need to do an import for what? 100 colon Which packet content? The data packet or the control plane? Data packet does not contain RTs at all. What is that's a question that Hari asked earlier on as well. What's the purpose of the RT? RT only plays around with what? With the control plane. It is to take the route and put it into the appropriate routing table. Once the route's in the routing table, then you have the labels that can come into the picture. The RTs have nothing to do with the actual data packet. The label is used for the data packet. So RT is just to make sure the route gets propagated into the appropriate routing tables, the VRFs. That's it. Data plane never uses RT. Let me ask you this. When you send a ping packet, what routing protocol am I running over here? First of all, just to make you understand that. What routing protocol am I running over here? IGP. Learning? I'm running what? EIGRP? When I do my ping packet, which is my data, in that ping packet, would you ever see on R1 going to 4, would you ever see EIGRP in that ping packet, the data packet? No, right? Why not? Or the metric for EIGRP? Because that has been done already to populate the routing table for the appropriate forwarding of the packet. At that point, when the route is in the routing table, it doesn't matter what routing protocol was used to put the route in the routing table. It doesn't look at it from EIGRP to OSPF. That decision has been made when the data packet comes and says, how do I reach this network? So at that point, EIGRP, OSPF, none of those things play a part in it. So the route target is part of your control plane. It's the time that BGP exchanges the route. So it won't be in your data packet. Same question that Hari was getting confused with earlier on. Right, Hari? Now, what does play a part over here? See, I have my control plane, and I've been telling you that for my control plane to work, all I need is IP reachability between what? These two guys, IP reachability, right? What if I take out MPLS over here? I do a no MPLS IP. On this link. Would my route still propagate? Yes, my route will still propagate because for propagating my route, all I need is IP connectivity. But my ping will not, because that would expose my VPN traffic in the middle. That would be your issue. Let's do that. This is something that you might get as a troubleshooting. So if your route is in your routing table, but it's not getting reachability, that would be the cause for that would be the missing of the label. So on R2, I'm going to go to E01 and say no MPLS IP. And this would be good enough, but just for the heck of it, I'll also do it over here. Okay, LDP is gone. Now I want to make sure you guys understand that although my LDP is gone, I'll do a clear IPBGP asterisk soft. So you know it's a new set of it's resetting or updating your BGP table. I did that. Take a look. If on our R8 I still have my routes. You see that? Even after doing what? Clear IP BGP asterisk soft. And I'll do it on all the routers just so that you guys see that. I'll send the command to all my sessions, clear IP BGP asterisk soft. So it's going to do it to all the routers over here. Okay? And you'll see that although I'm not running MPLS in the middle, my routing propagation is still there. So I should still see my routes. Do you get my point? Just because the routes are there doesn't mean my ping will work. Why is the ping not working? Because the packet is an unlabeled packet for the data plane in the core. And that is causing the packet to be exposed, the inner packet to be exposed in the core, and they have no idea about 10.1 or 10.2 or 10.5, those routes. So if you get into a situation where the routes are getting propagated, but you cannot ping it, same thing, it wouldn't give you too much of detail, say where it's getting broken, but again, not too much information. You see that? Because I don't have end-to-end reachability, so it's going to drop it. So this is a typical example of where your labeling will not break your control plane, but it will break your data plane. Yeah, now it's looking at the private address. So if I fix it, so I go in under the interface and say MPLS IP and go to router 3 and do the same thing. The name relationship should come up. There you go. I've broken in 2 places. Yep. And now this guy will work. All right. Any questions so far? Think we won't have time to do the rest, so we will do it tomorrow. Tomorrow I'll combine these things into one. Oh yeah, let's just do this. This I want to do. This part we'll do tomorrow. I want to get this done. This is the last thing. And then we'll call it a night. I haven't saved it. Day 2 notes. All right, so what I want to do, I want to show you guys something else over here. I'll bring this topology down. And instead, I'll use a different topology over here. I'll launch it. I'll explain it. Is this the right one, or? Yeah, we can do this one. Oh no, this is not the right one. Sorry guys, this is the wrong one. This is a bigger one. It's similar, but it won't match my diagram. MPLS RR example to organize this. Yeah, this I think matches my diagram. All right, let me explain this to you guys. But before I do that, to save some time, I'll open and launch my devices. All right, let's understand this. What I showed you has limitations. What are my limitations in the topology that I showed you? I showed you a very small topology. You guys pay attention. This is something that is a typical SP type of scenario. I showed you a scenario where I had one PE router here and I had another PE router over here. Do you guys think the service provider only has two PE routers? Generally not, right? But if you had multiple PE routers over here, do you want to do a full mesh type of topology with all these four routers? No, you would do it through an RR. Perfect. So I set up my RR over here, and I have all the neighbor relationships formed based on the RR. Good so far? Do you see a drawback in this topology? Besides a single point of failure, let's put another RR over here. Do you see an issue over here though? The issue that you see over here is that all traffic goes through the RR. Because now the update is going, because my way that the PE routers talk to the RR, PE routers talk to each other is through the RR. Although, if you guys have worked with the route reflector in detail, the RR never changes the next hop. Even if you put the next hop self on it, the RR would not change the next hop. But the thing is, the way the topology is set up for PE1 to talk to PE2, they would need to go through the RRs to get there. So this router now becomes your bottleneck for data traffic. So rather than doing that, what you do is you set up a different network over here, different device that is just used for traffic, data traffic. It's a fast speed, maybe a switch, maybe a nexus, maybe a fast speed ASR, which allows you the ability to send data from this side, whereas my route, my control plane is going through what? Through the RRs. How is that possible? The reason is when PE1 sends a route that it has learned to the RR, RR reflects the routes to PE2, PE3, and PE4. Let's say the route coming in was 10.5.5.0. It sends it to the RR, RR sends it to the other PE routers. When the other PE routers receive it, their next hop for 10.5 would still be what? PE1's next hop. So next hop would be, let's say, 1.1.1.1. You understand that? Because RR never changes the next hop. So when PE2 wants to get to 10.5, which it received from RR, but the next hop is PE1, it then looks at the IGP metric to reach 1111. And if you have set up a data plane traffic where you can set the better metric for IGP to reach P1, P2 to P1 through this. It's not going to go through the RR. This allows you the ability to have control plane go through one way and data plane go a different way. You guys understand that? This way, your RR can be optimized by getting more memory over here, because his main functionality is receiving the route and propagating the routes. And you can get this speed, this device, maybe a switch, maybe a router, with high speed interfaces. Where this is optimized for what? Data plane traffic. You guys get my point? So if you look at our topology over here, I put in as cust A and cust B. I'm going to put everything as cust A so you guys can see it. So what I'm doing at my topology over here, for my MPBGP, this is my route reflector. These are my PE routers. Although I'm showing you cust A, cust B, I'm going to set everything to be cust A. So these are 4 sites for the same customer. I'm going to set up a BGP relationship like that over the 192.1.10, 20, 30, 40 network. But my data plane, I'm going to set it through the 100 network, where all these 4 devices are directly connected to each other. So to get from R1 to R2 or R2 to R1, they all go through this common 100 network. So when this guy wants to send the route propagation will take place from where? R5 to 1, 1 to R9, R9 sends it to 2, 3, and 4. But when the data plane traffic comes in, where this guy wants to reach that network, he'll send it to him, go through the green network, and come this way. Again, I'm just showing you one RR and one switch. You might want to put another switch and another RR for redundancy over there. But the main point that I'm trying to get over here is the segregation of what? Data plane and control plane. My control plane is through the route reflectors. My data plane is on the switch. So technically speaking, if I want to, I can actually not run what? MPLS IP on these links, because my data plane is going through the green network. You understand what I'm saying? Remember, I showed you over here, my data plane is not going through it, so I can actually technically run MPLS only on the green network, not on the route reflector, if I want to. I would want to keep it over here as a backup, but technically I don't need to. Let's set this network up real quick. All right, my devices are up. R1, R2, R3, R4 are my P routers connecting to 5, 6, 7, and 8. This is my route reflector. You guys remember the 5 steps to set up MPBGP? Remember these 5 for MPLS VPN? Let's implement them now. And this would be our last lab for the day. Step 1, configure SP with a IGP. Let's see what I have right now. I need 9 as well. What routers do I have? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, good. So let's start with R1. I don't remember what I have done over here, so I'll just verify. Show IP interface brief. This is my common network, 100. This is the network towards the RR. This is my network towards my customer. This is my loopback I might have. This is the loopback that I'm going to form the neighbor relationship. So I really don't care about both of them. I'll just use one of them. I'll set the neighbor relationship based on 10.1, which is loopback 10. But before that, the first thing that I need to do is run what? Some form of an IGP over here. Show run section router. I don't know if I'm running. No, I'm not. So let's start with that. So we need to do the full lab from scratch. Through my IGP, through my SP core, I'm going to run an IGP. How do I do that? Router EIGRP, let's say 1. You guys don't like EIGRP, so let's do OSPF1. The thing that I need to check now is show run. And this is where, even with OSPF, somebody asked me this question earlier on. Loopback 0, no, loopback 10 is what I'm going to use. It's 10.111.255.255.255.0. See over here, I'm not running /32, and I'm running OSPF. But because of OSPF running with the, what do you call it? The OSPF network type, point to point, I can still make it work. So before I go to OSPF, I'll say interface loopback 10, IP OSPF, network, point to point. OSPF network is 192.1.100.0. Area 0, network is 10.0. This is the network towards my route reflector, and I want to advertise my 10 network. And I made the 10 into OSPF network point to point. This is my SP within core, what do you call it? IGP. So R1. This looks good. I ran it over here. I ran it over here. And the 10 network. The 15, I'm going to run it in my PEC. So I'm going to leave it off. For R2, so let's see how long it takes. It's about 132 right now to set the whole thing up. So R2, I'm going to do the same thing. 100 is there, but my other network over here is 20. You can verify that on router 2. Show IP interface brief. I have 20 and 100. This is the network towards the customer. I'm not using 2. 10.2 is the other network. So again, over here, I will change this to 20. 10 is okay. 100 is okay. Change the OSPF network type point to point. Go to router 2 and run it. Go to 3 now. My other PE router, show IP route, same thing. Actually, show IP interface brief. 130, 100, 30, and the 10 network. So again, same thing. Let's do this over here. R3, 100, 30, and the 10 network. I should form OSPF neighbor relationships because these guys are on the same network, the 100 network. That's that switch network that I have in the middle. Show IP route, OSPF, there you go. I got 10.10 and 10.20. Let's check R4 now, my last PE router. He's going to have 100, 40, and the 10. Let's verify. 140 and the 10. So it should have 3 OSPF neighbor relationships. That should come up from 1, 2, and 3. There you go. Show IP route OSPF. I should have all the routes. So I know if I want to reach 10.1, 10.2, or 10.3, I go directly to them through the Ethernet interface. Now the last router in this core is my route reflector, which has multiple interfaces, 192.1.10, 20, 30, 40, and the loopback. So let's do that one now. We'll verify it as well. 9. I have 10. I have 40. So I'll do 20, 30, 40, and 100. And the loopback 10. So that's this guy 9. Let's check the interfaces. 10, 20, 30, 40, and 10, 9. Everybody following along, guys, what I'm doing over here? Just setting up the basic IGP within my core network. So I have reachability to all the loopbacks. Yes, come on. You guys there? Everybody okay with step number 1? I've finished step 1 right now, which was configure the SP with an IGP, the core. That part is done. So now let's go to the next part. Configure the SP core with MPLS unicast routing. So R1, what are the interfaces that I need to run it on? I'm going to run it on E00 and E01. E00, E01 on R1, R2, R3, R4. So again, MPLS, LDP, router ID, loopback 10, which is the interface that I've advertised. Interface E0/0, MPLS IP. Interface E0/1, MPLS IP. R1 is done. Okay. Let's do 2 now. Same 2 interfaces, E00 and E01. Three. See, my LDP neighbor relationships are coming up. And 4. So my PE routers are done. On my R9, I have multiple interfaces. So I need to do more interfaces over here. 00, 01, 02, 03. So a little bit more. Nine is done. Let's run it over here. My LDP neighbor relationships are done. Step 2, you guys are okay with it? Which was configure the SP core with MPLS unicast routing. Yep. All right, now let's go to number 3 then. BGP. I'm doing the route reflector, so all of these guys will form a neighbor relationship only with whom? 10.9.9.9, the route reflector. Okay, so how do I do it? And this is MPBGP neighbor relationship that I'm going to set up. So let's do that on R1. Router BGP 100, neighbor 10.9.9.9, remote AS is also 100, neighbor 10.9.9.9, and my update source is loopback 0, because I want to do it for MPBGP address family, VPN v4, neighbor 10.9.9.9, activate. Oops. Thank you. All right. So this part should set up my neighbor relationship from the PE router towards the route reflector, which is 10.9. Copy it. Let's go to router 1. Set. Now the thing is, if you take a look at router 2's config, it's going to be identical to R1 because it's only pointing to the RR using the same IP addresses, same source interface, everything is the same. So if I go to router 2, my config will be identical over here because all the PE routers are forming a neighbor relationship towards the RR. So I go to router 2, set the relationship, R3, again the same, and R4, the last one. Again, towards the RR. Everything is pointing towards the RR. Good so far, guys? How about the RR? Now, RR, the best way to do it over here is to use a peer group. Loopback 10 over here as well. So what I'm going to do over here for R9, which is my RR, router BGP 100, neighbor IBGP, peer group, neighbor IBGP, remote AS 100, neighbor IBGP, update source, loopback 10, neighbor 10.1.1.1, peer group IBGP, 2, 3, 4. Yeah, it was 1,000. I've done 100, so let's just stick to 100 for now. So this is my IPv4 BGP that I need to set up, remote AS, update source loopback. Then don't forget, I need to do my address family, VPN-v4, here, neighbor, 10.1.1.1, activate, neighbor 10.2.2, activate, neighbor 10.3.3.3, activate, neighbor 10.4.4.4, activate. Don't forget, I need to be the route reflector, so I'll just do it for the IBGP peer group. But notice I did the route reflection where? Within the address family VPN v4, because the only routes that I'm propagating over here are your VPN v4 routes. So this is my config on R9, and it should set up a relationship with all the other devices. Something wrong? Ten nine nine nine. Just make sure config done this up. That is strange. What was it doing it? Let's do a simple one first, just to see. Neighbor 10.1.1.1, remote AS 100. Neighbor 10.1.1.1, update source loopback 10. Ah, loopback 0. Should be loopback 10. That's no worries. The good thing is it's the same config on all the routers. So all I got to do is no router BGP 100. And 4. Done. Now I can just copy this. Should be good to go. 9. Looks it's like it's up. I'll get rid of it because I had done some config over here. So I'll just paste the config all the way from scratch. Now I should have 4 neighbors up. 1, 2, 3, 2, 4, and 3. So my MPBGP is set up. So these guys are using this as a route reflector. R1, R2, R3, R4 are pointing to it. The neighbor relationship is up. So my next task after this was to configure the P router with the VRFs. So again, A, configure the VRF. Let's say VRF definition, cost A, RD, 100:1, address family, IPv4, route target, both, keep it simple. B, configure the interface. So this is on R1. R1, the interface over here is E0215. So this would be interface E02, VRF forwarding, cost A, IP address 15.1, no shut, and then the C, the third step, run the PECE protocol. So I'll say router BGP 100, address family, IPv4, VRF, cost A, neighbor 192.15.5, remote AS. We'll keep 65001 for everyone, but then I'll also do neighbor 15.5 AS override. That's my PEC protocol. Let's see if it works. Let's start with 1. Looks like it. Everything looks like it went fine. 15.1 is done. Now we'll do router 2. Router 2 is 26, 2 to 6, with this being dot 2. Other than that, everything else should be the same. So R1 was done. This is R2. This remains the same, the VRF portion. The interface is the same. The IP address would change. 26.2 is my IP. And when I run the routing protocol, I'm going to point to him as 26.6. And same IP for my AS override. So router 2 is done. Router 3 is 37.3 and this is 37.7. So let's do this over here. R3, the first portion is the same, 37.3. Address family, this is 37.7 as the neighbor. Looks good. R3. And the last PE router, number 4. Everything else is the same, 48.4. And 48.8 is my neighbor. And the AS override. So all my PE routers are done. Now the CE routers, the last step. R5 through 8. R5, R6, R7, R8. Let's see what I have on R5 first. So let's start with 5. What do I have? Show IP interface brief. I have the 5 network. We'll change it to 10.5 because these are private sites. Okay, I'll do it in Notepad. So R5 interface, loopback 0, IP address is 10.5. I have the interface setup, which is 15.5, which is good. And then I'll say router BGP 65001. Neighbor is 15.1. Remote AS is 100. My network is 10.5. So it should form a neighbor relationship. 15.1 is pingable. Neighbor relationship up. Show BGP, VPN, V4, unicast all. I should do an alias. There you go, first route there. And I'll do the same alias over here on R9. Now, one question I have for you guys. Notice I'm receiving 10.5 over here. In my MPBGP table, because this is the actual command. How am I receiving it here? Remember that BGP default route target filter? Should I be receiving it here? Think about it. Remember what I told you, that when a route gets propagated from year to year, if I don't have a VRF with the import RT, it should not take the route and put it into the VPN v4 table. You guys remember that? And I showed it to you as well. Absolutely. When you make a router into an MPBGP route reflector, it knows it's generally going to be in the center of the network and its only purpose is to propagate the routes to the other guys, he's probably not going to have a VRF. So when you make a router into an MPBGP route reflector, it automatically does no BGP default route target filter. Understood? So generally you would not see it because it's a MPBGP route reflector. It will take the route in, and not only will it take the route in over here, it will propagate the route to whom? I'll do the alias for show BGP VPN v4 unicast. I should see the route here as well. Do SVPN. Is that on the PE routers, or no? The disabling of the route reflection is only on the route reflector. But R2, R3, R4 are going to get it because they have the VRFs configured. They have the customer VRF. If I did not have the customer VRF over there, Ernie, I would not receive the route because I do have the VRF over there. And if you take a look at it, it has the import RT. That's why I'm receiving it over here. But the R9 router does not have any VRF, but he's still receiving the route and keeping it there. That's because of the RR. So that's the first one done. Let's do 6. In the VPN v4 table, I think, what is that given? Didn't get your, okay. So this is 65001. My neighbor on R6 is 26.6, sorry, 26.2. And the network that I'm advertising is 10.6. So R6 should be done as well. Show IP interface brief. There you go. Let's let the route propagate over here. Show IP route VRF cost A. There you go. 10.5, 10.6, and R5 now should see the route. Show IP BGP. I should see 10.5, 10.6. There you go. 10.5 local, 10.6 from the other side. So now over here, let's knock the last 2 off and we are done. Ten seven. This is 37.3. 7.7. Let it come through. There you go. The neighbor's up. There you go. 5, 6, and 7. And the last one, 8. Which is 48.4. 10.8. So this is this guy. Let it come up. There you go. Try P BGP to see the route. Now let me ask you this. In terms of the relationships that I set up, what is the path of the route propagation, the control plane? It is from R5 to 1, 1 to 9, 9 to the other guys. Isn't that true? But when I go over here on R4, let's say I want to go to the 10.5 network. The 10.5 network on R4 would be reachable via 10.1.1.1, which my routing table will say go through where? You understand that? Go through the switch. Why? For R4 to reach 10.1, this is a better path. Take a look at it. We'll do that. We'll do a trace route to verify that. Not only the trace route, but let's just do the route. Like show IP route, VRF cost A says to get to 10.5, the best route is through what? 10.1. And if you look at the routing table for 10.1, which was through OSPF, it's connected through 100.1, which is the Ethernet interface, E0. E0 is this interface, the one that I just showed you. So here. So my data plane is not going to take the same route as my control plane. So if I go over here and I do a trace route to 10.5555, source 10.888, notice it went to 4, and from 4 it went directly to 1 because the switch over there is a layer 2 hop, and then 5. So as I showed you, it went to 4. From 4, it jumped to what? Through the switch to 1 and 1 through 5. So I've segregated my control plane and data plane. This is a typical service provider network. Understood? As promised, today was going to be a fun class. I hope you guys enjoyed it. Don't miss tomorrow. Tomorrow, another good stuff, another thing that's going on is your, what do you call it? Inter-AS. A lot of good stuff in there as well. How do you connect two different autonomous systems to each other? All right, guys. You have fun. Sorry to keep you half an hour late, but tomorrow I want to finish everything up. So it may take longer tomorrow, but I'll try to knock out everything. Yes, let me just do that before I forget it. So this one first. Save. The eVlab, yeah, let me just do this first as well. This part is done. I can knock this out. I don't need this. I'll close this. Stop them first. Okay, where do I do this? Highlight it. Export. And this goes in here. Okay, now upload. Videos, I want this. Where is it? Show classes. Okay. One I had done, two I had done. This one I need to send, and this guy and this guy. And the second one. Send both. I don't know which one is which. One, two, three, the MPLS RR. This is your flow chart that I showed you guys today. Notes, the two notes are there as well. I'll upload the video after it's done rendering, probably sometime tomorrow. All right, guys. Good night. Good day. See you guys tomorrow. No worries, man. Take care.